We are going to make a wireless switch which will work on RF frequency. We can switch on and off 4 devices which is working in 230 volt using this circuit. This circuit is very cheap to assemble. This is RF transmitter and receiver module which is working in 433 MHz. Whatever digital data we are giving into the transmitter will be transmitted and received by the receiver module. This module is using ASK or amplitude shift keying technique. ASK is a type of amplitude modulation which represents the binary data in the form of variation in the amplitude of the signal. Since this is using amplitude modulation, the range of this module is high. This module will work in 3.3 to 5 volt. With the help of this module, the transmission of data became very simple. Implementation this in any circuit is also very simple. We don't need to worry about the complications of modulation and demodulation. Everything will be taken care by this module. This module is very cheap too. I will add the buying link in the description box. You can buy it from your local market as well. This is Encoder IC HT12E. This is an 18-pin IC and this is its counterpart IC, that is decoder IC HT12D. This is also an 18-pin IC. Both are 4-bit data IC and also 8-bit address bits are available. We are using encoder IC in transmitter part and decoder IC in receiver part. I prefer to use a common PCB for assembling the components than soldering it directly to the component leads. But for newbies in electronics, I am doing this for you. For experienced peoples, I have added the circuit diagram at the end of this video. I have added 3 circuit diagrams in this video: a transmitter circuit, a receiver circuit and a switching circuit. When you are looking into the circuits without thinking, it seems complicated, but when you are again looking into the circuit, you realize that it was very simple and contains a very few components. Thanks to the transmitting module, receiver module, decoder IC and encoder IC. Directly we can switch 4 devices using this circuit. But in this video I will be showing how to switch on and off only one device. The transmitter and receiver is exactly same for switching 4 devices, but the switching circuit is different for each device. So for switching 4 devices you need 4 switching circuits. Don't worry, for one switching circuit it has only one IC with no components attached to it. But for driving a relay you need a BC547 transistor. That's it. Earlier, using this transmitter and receiver, I have made a water level indicator with alarm. I will add the video link in the description box, so those who have not watched it can watch it now. So many use cases are there for this RF transmitter and receiver. I will upload more useful circuits using the same RF transmitter and receiver in future in my channel. So please stay tuned to my channel. Please subscribe to my channel, and also if you like this video, please click like button. One use case is you reached your main gate in your vehicle at your home. Using one press in micro switch you can open the gate, and one more press in the same switch will close the gate. You press the next switch, then your car parking light will be switched on. Pressing the next switch, your garden light will be switched on, and pressing the next switch you can even switch on and off your AC. You don't need a smartphone for doing these operations. You don't need a Wi-Fi for these operations. You don't need any smart devices for these operations. All you need is these 3 circuits. If you have any more use cases using this transceiver, then please comment on this video. For this transmitter and receiver module, we will not solder directly into its pin. Instead of, we will be using a sockets for this. If you have any doubt related to these circuits, then please comment on this video. I am happy to help you out. If you are using an analog to digital circuit and its counterpart digital to analog circuit, then you can switch 16 devices using this encoder and decoder. All you need are converter ICs and 16 switching circuits. Please don't skip this video. If anything is noticing in between, I will explain you at that moment. So please watch completely. We have completed the transmitter part, but the problem is we cannot test this until the receiver is completed. If you have a CRO, then you can test this by checking the amplitude variation. But I do not have a CRO, so I will test this by assembling the receiver part. Let's start assembling the receiver. This is signal LED. When the transmitter is binded to the receiver, then this LED will light up, and when the signal is received by this receiver, then this LED will blinks. Using this LED, we can know whether the transmitter is switched on or signal is transmitting, etc. These are signal out LEDs. By looking into these LEDs, we know which switch has pressed in the transmitter. These LEDs are wired as common anode type, which means positive terminals of the LEDs are common. When the signal is receiving, that particular data out pin will be in low state or grounded state, and thus that LED will light up. I have used a 5 cm antenna. I made this antenna by coiling a sleeveless wire. If you are using 15 cm antenna, then you will get pretty high range. We have completed the receiver part and now testing time. I am using 3.7 volt 18650 lithium-ion battery for powering both circuits. Transmitter is now ready. I am inserting battery to the receiver module. You can see whenever I gave power supply to receiver, the signal LED lights up, which means our transmitter is now binded to this receiver. We can see whenever I press the micro switch at the transmitter, the corresponding LED will light up at the receiver, which means our transmitter and receiver section is working perfectly fine. Now we will do some monkey testing. This will help us to know the durability of the circuit and its components. TV remote, you know its size. Here you can see the size of the whole components. Battery is taking pretty good space, else this is very compact. If somebody is telling that TV remote has so many functions, then I can reply that by adding ADC to this module, you can even increment its functions. Now it is time to make switching circuit. Here the circuit is wired using famous decade counter CD4017. Everyone knows about the CD4017 IC. This IC is used in LED chaser circuits. In my channel also I have used this IC for so many types of chasers. Here we are using this IC for switching a BC547 transistor which is driving the relay. Here the output from the decoder is given to the clock pulse input pin of that IC CD4017. So when we press micro switch, the decade counter gets one pulse and now the output will move to next pin where the relay will becomes on. When we press the same switch once again, then again the decade counter gets one more pulse which will move the output to the next pin. Now the magic is the third output of a CD4017 is given to the reset pin of the decade counter, which will move the output to the first one where relay will becomes off. One more thing you have to remember is the output of the decoder is active low type, which means whenever it is getting signal, the output will becomes low state. But decade counter clock pulse input pin will work at active high state. So for inverting, we use a PNP transistor BC557 in between decoder output and decade counter. Here I have assembled the switching circuit in a generic way. It can be used as a chaser or it can be wired as switching circuit. We can change its operations by using jumper wires. I will show you how it can be done. Even relay driver circuit is also isolated. Now we will assemble the inverting circuit which is wired using BC557 transistor. We need an additional 1K resistor for driving the transistor, else the LED will not light up, because when the base emitter junction is forward biased, the potential difference will be 0.7 volt, which is not enough for the LED to light up. We are switching a 230 volt load through the relay. So please be extra careful as 230 volt is very dangerous. And now comes the testing time. I am powering the transmitter now. The transmitter is now on and ready. Now I will power the receiver part. Do not touch the relay as it is connected to 230 volt supply. You can see the signal LED is on, which means the binding is complete. Please watch the LED bulb. I am pressing the micro switch. You can see the LED bulb becomes on and off whenever I press the switch. This switch is actually connected to the switching circuit. If you want more devices to be controlled, then add 3 more switching circuit with the BC557 as inverting transistor. Please listen the relay tick tick sound. I feel it will be better if you are using a 60 watt incandescent lamp than this LED bulb. The bulb will become really hot, so better to put the bulb on top of this cardboard carton box. Now again we can test this. You can see the bulb is lighting. Now I will place the transmitter in the balcony window. I believe that you loved this video. If yes, then please click like button and also share this to your friends. If you have any doubts, then please comment on this video. Please subscribe to my channel for getting more videos like this. That will be an encouragement to me for making more things like this to you. This is Tech Insert signing off. See you in another video. Till then, goodbye and please take care.